board, that would be awesome.
We're all set.
All right. And so I don't know if you wanted to give some context and background or.
Yeah, definitely.
Sure. Okay.
So hi, everyone. Thanks for joining this special community session. Today's Monday, July 6th, and we are going to be performing a deep dive on the restore hooks for Velero extensibility this morning. I will start sharing my screen so that I can show you all what we have in terms of definition for this requirement so far. And I'm getting that prepared. I was having a couple computer issues this morning, but we will be performing basically a deep dive on the product design that has been very actively worked on by members of the community, as well as some of the internal VMware team members, and we really appreciate the feedback. And we will also be looking through the product requirements documentation. So the design for restore hooks is what I am sharing on my screen now. We have issue 2609 and the design proposal associated with that as well, that Mark Campbell has done a lot of work on, as well as Adam Reed, which is number 2465. We also have an issue which is related to the product requirements that are tied to the restore hook epic. All of the items are linked there. But for today, we've had a lot of feedback on the design proposal for restore hooks. And that's what we want to spend some time diving into today. It's been discussed a little bit on some of the community meetings, just at first glance, and some of the use cases defined. But we're going to be taking just a deeper look at it today. So Nolan, I'll let you take the floor from there, and I will stop sharing my screen.
Yeah, so I think the reason we wanted to dive into a special session like this is what we were running into with the current design proposal was that the proposal as is proposes that we would start up pods with a hook and execute a command in those pods, allow them to get adopted by whatever controller would be managing them. So stateful set, deployment, whatever might be managing those pods, might even be a custom controller. And then Velero would run the restore hooks in that context. The issue raised in the PR was that it's possible that the pod could start up, do some work, and then Velero could come in and run the restore hook and get interrupted or interrupt the work. At some point, there's a race condition, essentially. Whether it's the restore hook starting too early, or the pod itself starting the workload or starting the database too early. And we kind of wanted to work in a little bit more synchronous manner instead of going back and forth on the design proposal to say, what's the best way to address this. So one other idea was to attach init containers to restored pods. So basically manipulate the pods and say, here's an init container for your restore hook. Details there aren't fully baked yet, but the init container would essentially be where the hook runs to put the data in the right place. So maybe it would run for a database, maybe it would run the whole database, maybe it would just copy data into a well-known location. That would probably boil down to your application. But the idea would be that the init container would run prior to the application starting up. So that way it removes the race condition. The current issue that I think we're struggling with there is making sure that we coordinate multiple instances or replicas. I think most database systems are okay with this as long as we can guarantee it only happens once. The other issue that's going to become relevant for Velero in a few releases is making sure that this is idempotent in restores, so that if I have two restore operations happening on the same workload, that Velero doesn't blow away the data or have race conditions in the restores, because right now Velero does one restore at a time. But in our roadmap, we want to get Velero opened up and be more concurrent and, you know, behave the way people really expect it to in a Kubernetes cluster, so that it can do basically as many restores as the cluster could handle. So I think those are the two main issues I see right now. Is three, making sure we populate the database or application. I'm using database because I think that's the most common application that we're experiencing trepidation over. Making sure we coordinate in case the application matters, that there's, you know, multiple nodes that it matters. A lot of databases can manage this right now, but not all of them, I'm sure. And also making sure that this design, since we're doing it now, making sure the design can stand up to Velero becoming more concurrent and parallel. And I'll ask, is that a fairly accurate summary for like Mark and Ashish, since you two have been pretty engaged in the conversation? Is that a fairly accurate summary?
Yes, I would like to add or clarify one aspect, which is you said it would be sufficient to run this hook on one of those pods if we are running multiple replicas. But it may be the case that if the database is like a quorum-based database, you will want to run it on multiple or majority of the replicas. So that is another thing that we may want to keep in mind.
Okay, good point. So yeah, given those, I don't know if folks have read the proposal or if we want to share it. I didn't have time to put together graphs or anything, but I will also mention that upstream is a proposal for modifying the kubelet for something called container notifiers, that we would love to use, but that's still very much in the early KEP phase. And frankly, I don't know if it will even get accepted. So we kind of want to put something in sooner rather than later, rather than waiting for the Kubernetes feature. When it comes, we will gladly kind of move there. But for now, we would like to get something that lets users use the data that they quest in our backup hooks and get it going. Our stated goal on the roadmap is to get this out in a 1.5 August timeframe. I don't 100% know if this is feasible. Frankly, we'll need community help to be able to hit that. But it also depends on like what we come up with the design here. So I think I'm gonna open up the floor and let people discuss here.
I think it would be useful to know how folks are dealing with this without the feature built into Velero. Maybe that will give us some direction.
I can sort of talk about what we're doing in the Tanzu platform recovery team. And it's still a bit loose because we're not that far down our roadmap. But our workaround at the moment is writing some scripts to orchestrate some of the functions that would happen in a restore hook. So one of our use cases right now is to not just back up a database that is on Kubernetes, running on Kubernetes. It could be a database that is external of Kubernetes, but because it's a part of the platform that's running, we believe that the backup restore functionality has to include that database even if it is external. So for example, what might happen is the Velero restore will have occurred, put the backup of the database on the persistent volume of our pod that is going to then restore that into an external database that's not running on Kubernetes. So that's sort of like one of the use cases that we're aiming for. And our workaround is to just script that. So Velero runs, we get some data on the persistent volume, and then we can do a kubectl execute to perform that. So that's one sort of concrete example. We're not that far yet, but that's what we're aiming for.
I can give another kind of concrete example. It's not that different from what Scott just described. One of the differences are that we're actually running our database inside Kubernetes as a stateful set. And it's, in this example, it's Postgres. But what we've done is we've attached a new empty dir volume PVC to Postgres and included just the empty dir in the Velero backup, not the actual main PG data directory. And we have a pre-backup hook that does a PG dump from volume A into volume B. So the PG dump data is the only thing that gets backed up. We inject an init container into Postgres that has a custom bash script in it. Sounds a little bit like what you're doing, that looks for the existence of data in this empty dir volume that would signify that we're in a restore mode. And it will do a PG restore back to the main one. Postgres is already started up. We have the race condition there that Nolan spoke about for a minute. And then it deletes the data so that it becomes an idempotent restore. It's a little bit fragile in the fact that if something goes wrong, it's going to be stuck in a continuous restoring process there. And that race condition creates a problem. We've done a couple of things to kind of work around the race condition experimental that we haven't moved into production yet. One being, instead of doing a PG restore, we just copy the thing into the well-known location, because Postgres and MySQL and a lot of database containers just have well-known locations. And we've actually even taken the extra directory out of our Postgres stateful set and moved it into an API workload that we have that can talk to it. Because the problem with the init container also was that like Postgres had to be running and available. And so now in an init container, as an init container in the API, Postgres can start up, but the API that we have in our example workload, again, just talking about how we're working around it, like now Postgres is starting up, but because the API is in init container mode, we don't really have an application level race condition anymore, because no data is going to be written to that until the API finishes its PG restore, in which case everything is now healthy again.
Mark, I have a question here. Let's say you've run, let's say you've done a restore of that once, and then you take a backup of that again, and then you try to restore that again. Does that init container stick around so that do you get copies of that init container on another restore? Is it intelligent enough to detect that the init container is already there?
Yeah, that's a good question. We're like, our application starts up, it's like very tightly integrated into Customize. And so the init container is injected in at the last minute using Customize. So like there's always one. But like, yeah, that would be a problem if we were trying to declaratively describe this YAML as a single manifest.
I have another example that we're not that far down yet, but related to the hook and the life cycles of things. It's maybe not necessarily related to backing up and restoring of actual data, but it's around providing the metadata of the contents of the backups and the contents of what got restored. So currently we're implementing in our hook something that emits some log output that can be then retrieved later on and parsed and then say, okay, this is the contents of specifically it's with Cloud Foundry. So we want to see the orgs and spaces within the Cloud Foundry that got backed up. And we don't have it in our roadmap, but a use case could be, I've now performed a restore and I'm going to invoke some code to obtain the metadata of the Cloud Foundry that we've just restored. Does it match what got backed up? That kind of thing. So it's the life cycle events are definitely important to hook certain things on for the operators of this.
So I've heard both of you say you're basically taking some data. In Scott's case, you're taking data external to Kubernetes and shoving it into a PV that's specifically for getting included in a Velero backup. In Mark's case, you're taking a production PV and putting it into a snapshotting PV. Is there anyone that's doing a use case that's different here?
The only comment I can make is that I was in the past in Elastic, so it's not just Postgres. There will be different, stateful applications that has their own mechanism of managing, quiescing, snapshotting, and restoring, and they need a bunch of operations before and after.
Yeah, and I realize that and I think in both of these cases, part of what they're doing is getting around how Velero currently works too. Like those in the external, both the external system and in the production PV, like I'm guessing that production PV isn't managed by Velero, Mark, if I'm guessing.
Correct.
Yeah.
But I think it doesn't really matter if the database PV is managed by Velero or not. I think what the use case implies is that the same way that you want to do some actions on systems before you snapshot their data, sometimes the same systems needs to do something either before you start them with the attached restored PV or after, in order to recover to production mode, right? So
So this to me sounds like a need for a more of a volume restore hook rather than a pod restore hook. So meaning we don't run these restore actions on when we restore pods of applications, but we run this hook on restoration of volumes. So we restore volume, populate the data, and and kind of tie the pod and the volume together when we restore the pod.
Shisha, I think one of the challenges that we run into when we kind of think that path is it works often, but there's definitely some systems, databases in particular, that like the database engine needs to be up and running, the pod needs to be available. We can't manipulate the volume without also having a database engine running and it's attached to it.
Okay.
I would actually say that's the majority of cases with databases, not the minority
Yeah.
of cases.
Yeah.
Yeah, in Ashish, your statement, I'm going to link this in chat. When you say like this is a volume restore hook, like this makes me think of this KEP, this generic data populators, which is again like these generic data populators would be an awesome thing once they actually exist, because then the database could be running, right? You could have a Postgres or an Elastic or I don't know, like you pick your database. You could have a generic data populator that exists for that engine. And to explain further, here I'll share my screen. So to kind of this is again, this is kind of based on this is going to take a long time to get going because it's based on manipulating the Kubernetes API. The idea would be you can set a data source on a PVC to a custom resource object, and you could then have a controller or a operator that would fill it, and then Kubernetes would not declare the PV as ready until this operator returned the PV to you. But again, this is not something Velero can take advantage of yet. So I guess I want to let people know this is out there, but we can't use it today. But if we pull the discussion back in to what we can do in Velero today, if we had an implementation that attached to the container as init containers, or attached to the pod as init containers. Let's say it was a deployment and we attached it and did it as every pod. So it ran against everything in the deployment. I recognize it's not going to be 100% the case. Like I think we need a switch there that says run this on everything or run this on one. I think we need a way to determine that, because it's not, we Velero right now do not have a way to introspect the application. I don't know that we ever will until we get like some sort of, whether we use Helm or YTT or whatever. We don't have anything that tells us about the application. Scott.
This isn't totally directly related to the restore hooks, but I think it's related to just hooks in general and how we're using them. And our use case at the moment is we are attaching, or we're adding the hook annotations to a pod, and it's a pod that is just in a for while infinite loop, because we have to have a running pod in order for the hooks to appear on. That pod does happen to be running a container that has some of our CLI tools that are relevant for our backup and restore needs. But I am curious about the fact that we're running a pod that is doing nothing for the purpose of hook, like hanging, well, I guess hooks are for hanging, but we have something to hang the hooks on, or it's the other way around. Sorry, I got lost in the English of it. But this is sort of what, when I heard Ashish talking about, like, should we have hooks on PVs? It made me wonder about like what is the appropriate place to hang hooks off of. So it's just putting that out there, not really seeking any answers to it, but that's our use case right now.
That's for your backup hooks?
Yeah.
Right now? Okay.
And eventually restore hooks. well, we'll see. But yeah.
No, and I had one kind of follow-up question to your statement too. Since we moved our backup over to the API and it's a deployment that's running, and that could, in theory, be multiple replicas, does Velero have? I'm not aware of any, but like you're definitely the expert here in Velero. Does Velero have the same concept of being able to say back up one pod from this deployment or replica set? I don't need all of them snapshotted.
Not right now. And I think what I was thinking of was more of a in the, let's say we chose to go with an that annotations method. It was to say of the restore hooks, we can say the restore hooks, this is a once or all kind of mode. So I run this restore hook on everything, or I only put this on one pod. And in that case, like the restore hooks would almost have to go on the container of the pods, right? It would have to go on the deployment or the stateful set or whatever the controller owner is. The hook would have to go there.
Yeah, that makes sense. I bring it up because like I know it's like very much out of scope of the restore hook conversation, but I think that annotation to say once or all like probably also translates to the backup phase. It seems super useful there.
Right. Yeah. I think like if we implement something here that would be useful for the backup hooks, it makes sense to move it over. And I think also there's specifically from the concurrency perspective, we're probably going to have to revisit backup hooks as we start looking at making Velero more concurrent. I think backup hooks are probably going to be affected. No, they will be. Not probably, they will be. Because like when you just quickly, when you're taking a backup, if multiple users are trying to, if multiple backups select the same volume, that data can't be FS freezed twice, right? For just to use an example of a hook. So yeah, there's multiple design concerns, I think, that will go from the restore hooks to backup. But I do think restore has some stuff that's unique to it versus what backup did.
Yeah, it might be inconvenient to have 3 copies of my Postgres data backed up, but it would be broken to restore it 3 different times or something like that.
Right. Yeah, and you don't want to overwrite it 3 different times.
Exactly.
And yeah, you also don't want to interrupt an ongoing restore to restore the new one because somebody else clicked the button.
Yeah.
Just so I understanding the current thread, are you talking about the situation where you're performing a Velero restore, and during that it recreates a resource that now has restore hooks? And so
I'm thinking about when we get to designing, or when Velero has become more concurrent and can do multiple restores at the same time. Let's say 2 people are restoring the same volume or same database. What happens? Basically.
Okay, you're talking from a multi-user restore process. Okay.
Or even the same user selecting the same database. What do these hooks do, or what does Velero do about that? It may be that these hooks are solely dependent on how Velero handles that resource. It says, oh, it's already being restored, I'm going to back off, because maybe that's the proper outcome, that Velero sees, hey, it's being restored, sorry, you can't do that.
So that's sort of, it goes to who who writes the concurrency controls? Are we leaning on the Velero hook invocation, or does the hook author have to own that?
Right, which currently, like, so the backup hooks, we kind of push that off on the hook authors. Here, I'm starting to think that's not great on the restore hook authors, because that just makes it a big pain to write these restore hooks.
The only ways to do that would be to do something like what Scott's doing, where you're just throwing a pod in that's in a sleep infinity or something along those lines, right? I would have to add a dedicated pod with or something with a replica count of 1 if I wanted to use a higher level order component than a pod, and say the thing exists only to do restores.
We're locking by accidental design.
So
Can we borrow? Yeah, go ahead, Mark.
No, Ashish, go ahead.
I was going to say, just to kind of forge a path forward, can we follow something like we do for resting, where we have a restic restore helper, which is like an init container, which waits forever while the volume that the pod wants gets populated. I think that is very similar to what, Scott, you said you were doing.
So are you saying like a Velero hook helper?
Yep. Which if there's an annotation on the pod saying run this restore hook, we can add an init container which waits for the pod. But then again, the issue there is what Mark brought up. The actual database application has to be running for the restore to actually run. So for PG restore, I think you need Postgres to be running. So you want Postgres to be running, but not accepting any traffic.
Right, but that's not on us to do. Like for us, like what I think what's there for Velero to do is to provide the building blocks such that it's safe for these things to execute and not step on their toes. And PG restore isn't the only way to get the data into Postgres. There's like copying it into PG data without it running. That's not to say Postgres is not the only workload to think about here, but if we have this like but yeah, I think that this may be this is one path I didn't think about.
I'm also curious to know what would in your all's opinion would be the MVP for this. We may get a starting point and then iterate on that and make it better.
The end, or the experience that we want to provide to Tanzu application service operators is they can restore their Cloud Foundry using Velero. So that's the end goal, end experience that we want to aim for. And so anytime that we instruct an Alana, that's our persona for a platform engineer, to do something that's not Velero to perform a restore, that's a gap that we want to see narrow. So I can't really say exactly what we want from the hooks perspective, but I can just articulate that's the restore experience that we want for our platform operators when they're trying to restore our product. which
From
I
our,
think, yeah, go ahead.
I was just gonna say from our perspective, COTS is it's a tool for application developers to distribute their application, and we have Velero integrated really tightly into that. And so we say, just, hey, here's the Velero docs, go here and like follow the process that you're using to to snapshot the application. And we get questions from application vendors constantly, when they're doing that around like, okay, that works, but like, what do I do about this restore? And we can help them say, just add this in a container and do this pod in, but like, I mean, we would like this to be as Velero native as possible so that we could just say, look, you used it in annotation to add a bash script in here in order to tell us how to get the data. Add an annotation in here that adds to like, that's the reverse of that. Implementation details, like very much open to whatever works. Like we're only coming with like our experience so far working with application vendors and how they're working around this right now, how they're actually able to do custom restore hooks, if you will.
So as next steps, do we want to do more investigation as to what works more generically, or what do we want to say init containers is the way to go, or?
From a technical perspective, I can throw in like, my opinion is that if we added in an init container process to the restore, and then we gave the user the ability to do that however they wanted to, they don't have to attach it to the Postgres or the MySQL or the Mongo workload. They could attach it to their own. They could attach it to something else. That you give the user, the developer, the ability to work around that race condition by attaching it other places. And to me, a restore hook that I can attach to any workload I want to feels like it's a potential MVP. And then iterating down the road is the ability to say like, one or all, or in things like this, where it allows the user to write less YAML and use the built-ins in Velero.
Yeah, and on the topic of one or all, I think it should still work if you run the restore hook on all parts of a application, right? So if you're taking a backup of Postgres and you have 3 replicas, the snapshot of each of those replicas will be at different points in Postgres, but they should all, like, once they come up, they should all converge.
So the way that Velero could enforce that would just be to make sure that it's not running 3, like it has to execute the restore hooks in the same order and sequentially that they ran in the backup, or are you thinking something more complicated than that?
I was thinking if there are 3 replicas there and each of them are at stage A, B, and C, and the converging, or the C is the most recent, regardless of what I start first, they should all converge to C. That's what I had in mind.
I think, and to clarify what it meant for like once or all, that was kind of building on what that was kind of like looking for a compromise between, I think it was Andrew that pointed out some databases, sometimes you only want to run it once, and something what Ashish mentioned was if you run a database that is, you're running it in a setup where you're quorum based, you could run it once and then have the database engine copy it out to the nodes. Or you could have Velero restore it with the restore hook and skip that copy point, that copy. But I think, I don't know how the mechanics of that would work, because we would have to get like fiddly with how, like if it's a daemon set, how would we exactly control which pod? Because if Velero lets the daemon set do the, like if we say we just restore the daemon set and let the pods go,
Yeah.
we would have to get real fiddly with how we like go in and edit the pods, or we would have to restore the pods let the daemon set atop them, and then we run into the problem which we talked about on the issue, which is the daemon set may destroy the pods and start up its own because it sees we edited them. So that the once or all thing may be its own design discussion. And I'm kind of thinking along the lines you are, Mark, that the MVP is like, we get some init containers that you can run things in, and let is getting closer to backup hooks right now, and letting users manage the concurrency and all of that. And then we iterate on the concurrency parts.
Yeah. I think that sounds fair to me.
And I agree with that approach, especially since concurrency is a little bit further down our roadmap. So I think it lines up really well for an MVP.
Yeah, I mean, in my opinion, I would love to, like, if it's something we could solve for now to make concurrency easier to implement, that would be awesome. But concurrency is going to be tricky to implement now that we're like putting it in later. I think there's no way around the fact that getting concurrency in Velero is going to be tricky. So I'm kind of hearing consensus that people are looking for more of an MVP along those lines. Does anyone have major objections to that? To the init containers?
I would just like to, so as you know, that we're running this like long running process pod to hang the hooks on, and does the init container solution, does it change what we do about hanging our restore hooks? Can we still hang the restore hooks on this running pod and run the restore scripts that we want in the pod, like the running container that's inside of our pod, and sort of not require a separate init container to run this stuff from? Or are these like complementary? They can both work together.
So are you saying implement the proposal as it is today, or that being an option?
I'd have to reread what the full proposal is right now.
Okay.
Because I think the thing that's new for me, or I'm not quite understanding, is if it's going to invoke or start an init container inside our existing long-running pod, I'm just not sure of what that life cycle looks like. Do we? Yeah.
My understanding of the init container would be putting the init container on the workloads pod.
Mm-hmm.
So this does, what you're raising is, it does create, like, there's a difference between how the backups run, the backup hooks run, and how these run, which I know Mark's original current proposal was trying to maintain like a symmetry between the two. So, okay, that I would have to think about. If we can accommodate running both, we would have to see.
I think it would be feasible to run both, right? So this would be like a annotation flag which says what mode to run it in. We can say run it inline or run it via init containers, and based on what we update the pod spec accordingly.
Cool.
I think that makes sense. I mean, we definitely have a lot of, we talked really specifically about our Postgres backup and restore, but we have other workloads that we're backing up and restoring that, some don't even need restore hooks, at all. And some of them can run totally in line, like, Minio and things like that. So.
And Scott, just to help me understand a little bit more. So for yours, do you have just like a backup hooks pod that just kind of sits there in a spin loop that just has annotations on it to provide everything? Is that what it does? It's all the tools are just sitting there in this pod, and that's all it does?
Yeah, so part of our deliverable is we create a custom Docker image that has our toolkit for backing up and restoring. And we have some pod spec that adds the appropriate annotations and a couple other things in order to fit in with the whole Cloud Foundry deployment.
Okay, so it's not, so you don't add, you don't modify workloads at all. It's
no
in this. Okay.
Yeah. So our interface to a database is a host name and credentials.
Okay, so then to fit into that, you would want like basically in your ideal world, you would maybe add the restore hook annotations just to this thing, or have a secondary pod. Yeah. Okay.
Exactly.
Yeah, I think in your scenario, because your database is external to Kubernetes, that would totally make sense, or make the easiest way to do things.
So did we come down to do both of the things we talked about? Knowing their limitations, we're going to do them both anyway. Which
so.
is yeah, I mean, that's a totally valid thing to do. We can document the limitations and let people know. I kind of view these things as being building blocks. Knowing there's going to be higher order things that people can build on top of. Maybe Velero itself can build on top of. But this gets us something. So that folks don't have to build kubectl, run Velero and then run kubectl afterwards. You can at least get started and have something inside of your Velero workflow. And I'm curious, Mark and Andrew, you had said you would be able to work with us on this. Is that still a realistic thing? After the design documents updated and everything, is it in terms of implementation?
Yeah, I think so. I mean, Andrew would probably be the one doing most of the actual implementation from our side. So
okay.
Yeah, I'd be happy to help out.
Thank you both. We really appreciate that. All right, so for next steps, we have a product requirements document that outlines some of the high-level use cases. We'll update some of the use cases discussed here, as well as the design doc. And then Andrew and Mark, we can continue the conversation in the community meetings and in the comments to get this moving whenever y'all are ready.
And when we get started, if we need to get together as a group to discuss more stuff, feel free to pull us in.
Yeah, I would say let's get the design doc proposal updated. We can compare against the use cases, and then we can move forward there. Thanks, Stephanie, for putting this together. Thanks, everybody, for jumping on.
Thank you, everyone. This is great.
Yeah, I think we have 4 minutes.
Yay, 4 minutes back.
Yeah.
Okay. Yeah, appreciate your time, everyone. Thanks.
Yeah.
thank you.
Bye. Bye.
Bye.